One of the areas that has seen considerable attention is that of location. The reason why location is important is that it provides context, and more importantly, context is extremely important for advertisements, which could be extremely lucrative from a marketing standpoint. The problem, though, is that indoor location is actually really hard, and even outdoor location is non-trivial once we start trying to figure it out on a mobile device. Determining one location seems like a fairly straightforward problem. After all, as a human, I simply look around my local area and look at various contextual clues or signs to tell me where I am and where I want to go. The problem is, for a smartphone or mobile device, this is not that easy of a problem. And in fact, your modern smartphone adopts a variety of techniques to help determine your position. At the core is a technology that most people are quite familiar with, GPS, or Global Positioning System. GPS, and for that matter, most location services, rely on a concept called trilateration. Trilateration works thusly. If I can get at least 3 signals emanating from 3 known locations, I can then determine where I am relative to those 3 locations. Let's walk through a simple example. Instead of satellites, though, let's think this through with cell towers. For any wireless signal, I can usually figure out what the signal strength is, or what we had previously called RSSI, or the Received Signal Strength Indicator. As RSSI gets stronger, that means that I am closer to a tower. As RSSI gets weaker, it means that I am farther away. With only one tower, I know how far I am away from the tower, but nothing else. In short, I have my tower, and my signal strength helps pin me on a circle around the tower. Since it is wireless, and RSSI can vary quite a bit, it's more like a big, thick circle around a tower. Not terribly helpful if my cell tower covers a few miles. Now, what happens if I add a second tower? Well, now we're getting somewhere. Now I have one circle from the first tower, and a second circle from the other tower. I have to be at a point where the 2 circles intersect. If I am lucky, that's only a small area. However, there are still 2 potential intersections where I can be. That's where the third tower, or point, comes in. If I have a third point, we drop down from 2 potential intersections to only a single area. Ta-da! Now I have a reasonably pinned area. I can, of course, add more reference signals to increase my accuracy. For GPS, my trilateration comes from sighting multiple satellites. The satellites help me out with timing and location information. Remember, they are also orbiting the Earth, and I get a rough position, latitude, longitude, and an error, 15 meters plus or minus, depending upon how many satellites I see. The circuits to do this are actually fairly complex, slow, and fairly bulky. Your modern smartphone actually does a bit of trickery and uses something called AGPS, or assisted GPS, that does a pretty good approximation with significantly less electronics. So now we know where our position is when we can see the satellites. What about indoors, though? Well, that is where we can use the same concept, but just use Wi-Fi to help us out. If we have precisely mapped where the Wi-Fi access points are, we can use the same principles to do indoor mapping, and our error drops down to roughly plus or minus 10 meters. Basically enough to tell us which room we might be in the building, but probably not much more than that. Companies, of course, now have been investing hundreds of millions of dollars to improve their indoor mapping, all in the hopes that you as the consumer will be swayed to buy more goods if they can get the advertising right because they know what your position is.